Good afternoon, everyone. Thank you for joining us today. So my name is Seher Sağıroğlu, Ayhan. I am working at ICANN as Global Stakeholder Engagement Specialist, and I am responsible for Middle East and Africa region. I'm assisting the teams in those regions. First, I would like to thank Enis Hocam for inviting us to this lecture and allowing us to meeting with you, and also allowing us to talk about DNS security, which we found it very, very crucial for the secure and stable internet. So today, my colleague Paul Muchene is being with us, and he will explain how we preserve the DNS as a critical component of a secure and stable internet. Paul is a technical engagement specialist for Africa and Middle East regions, and he holds master's degree from computer science from Georgia Tech University. So you will be colleagues to him. I mean, you guys are coming from the same background, not me. But I am thankful him because he will walk us through the details of this DNS security and the DNS infrastructure today. First, I will briefly introduce ICANN for those who haven't heard about it and who doesn't know us. And then I will leave floor to my colleague to provide some details. So throughout these presentations, we have some questions, but just I want to reiterate, we would like to have this session as interactive as possible. Please feel free to interrupt us anytime if you have any questions, and please always provide your comments and questions in the chat pod because I will be monitoring the chat pod at the same time. And apart from the poll questions that we prepared for you, we might have some, interactive conversations going along with this presentation. So now I want you to go to the website slide.co. Can you do that for me? And if you don't go to the website, you can just provide your answers in the chat pod, because we have a question for you. We would like to hear from you. So the question is, who manage the internet? And when you go to the Slido, you will see the code. And the code I am just putting into the slide. Oh, 328,448. Maybe I can just share my screen so you can see the screen. Okay, so when you enter into the slide.co web address, you just need to enter this code, 328,488. And I would like you to answer this question. I mean, according to you, who do you think to manage the internet? Is there someone, is there entity, is there any entity? So we would like to hear from you. But if you couldn't manage to get to this website, don't worry, you can just share your answers in the chat bot as well. I see one response. Just tell me, is it hard to get to the website? Yeah, the website is slido.com. I see non-governmental organizations selected. Oh, great. We have so far 5 responses. Users, this is a good answer as well. Non-governmental organizations. No one picked technical community. No one picked states. Yeah, majority of you selected all of the above. I am not proposing anything. I just let you to decide. And there is no correct answers, maybe. I don't know. Okay. And yeah, we have 11 responses. And the correct response is all of the above. So thank you for that. Because as you know, internet is a network of the networks where there is no single entity and there is no single authority to control, change, or manage the internet. The internet is administered by a loose, decentralized, and distributed collection of organizations and people who set the rules, standards, and policies. And also those people and technical communities provide technical support so that the world can be connected on one and global and single internet. So I'm going to stop my screen and then I will go back to my slide. So I will briefly talk about ICANN because I know that ICANN might be a quite new word for you. Just sorry. I just couldn't open the file. Right now we are here. Yes, I hope everybody can see my screen right now. Okay, so let me start with ICANN. ICANN is a non-profit organization, and ICANN is an acronym. The full name is Internet Corporation for Assigned Names and Numbers. So what is ICANN? As I said, it is a non-profit organization and it was formed back in 1998. And our mission is to help people, to ensure a secure, stable, and global internet. In general, we can say that ICANN is responsible for the management of unique identifiers. As you see on the screen, these are the unique identifiers that we are managing. We are managing, coordinating numbers that we use in the internet, names, protocol parameters, and I'm gonna go through these terminologies. But in managing of these, parameters and unique identifiers, we are not alone. We are closely working with different technical committees. As you see on the screen, these are the Internet Engineering Task Force. These people are creating standards for the internet today. And there are root server operators. There are several regional entities that we are closely working. And also we do have a lot different stakeholders coming from civil society and academia. But what we are doing, as I said, we are managing unique names and numbers. For example, let me just explain what are these names and numbers. So anything connected to internet, including computers, your mobile phones, even your smart devices at home. Each device has a unique address. We call it IP address, and as it stands for Internet Protocol Address. And just like the address we use in our daily life, the postal address we use in our daily life, this IP address allows us to send messages, videos, and other packets of data to another device, which has a unique IP address. So this number allows these devices to communicate between each other. But in our daily life, have you ever recognized that you use IP address? No, because IP address is very hard to memorize. Instead of using IP address, as a human being, we use names. We use names because we cannot memorize IP address, but machines can do, devices can do. But in our daily life, if we want to go to a website, we always use names. For example, whatsapp.com, facebook.com. You don't know which IP address stands for these domain names, right? But you have to keep in mind, every domain name is corresponding to an IP address to find to reach out in the internet. Let me go to another slide. So what are we doing in the internet? As I said earlier, we are managing unique identifiers, and those unique identifiers are names and numbers. So these slides might be complex for you to understand, but I would like to give a clear examples. Our main responsibility is to ensure stable, secure operation of Internet Unique Identifier System. So what we are doing, we are coordinating the allocation and assignment of names in the root zone. Okay, maybe it doesn't ring a bell for you, but I can give you an example. When you go to your browser, when you enter a domain name into your browser, for example, facebook.com, facebook.com is a domain name. .com, the part is .com is top level domain name. And all these top level domain names are assigned by ICANN. And also .com, .org, .net, all these terms are top level domain names. They are allocated by ICANN upon the request of the relevant authority or interested party. And also ICANN is helping the community to provide policies with regards to these top level domain names. It means that when you register a domain name under .com, .net, .org, .istanbul, .google, there are some specific policies and regulations governing those areas, and those policies are developed by ICANN community, not ICANN itself, by ICANN community, including states, including civil society organizations, including end users like us. And we are also here to facilitate the coordination of the operation root server system. I will not get into detail about root server system because I know that Paul will do at some point. And also, we do some allocation and assignment at the topmost level of Internet protocol numbers, autonomous system numbers. Another clear example for this, you have a router in your house that connects you to the Internet, right? And this Internet connection is provided by the Internet service provider in your country, for example, Türk Telekom, for example, Turkcell, whatever connection or whatever operator you are using. And all these Internet service providers are using autonomous system numbers and Internet protocol numbers to get you connected to the Internet. And the allocation of these numbers are also managed by ICANN. And also we are working with registrars and registrars who are registering domain names on behalf of you, or selling domain names and managing the domain names area. And we are also helping to those parties. I know that there are many new terms that is being used in these slides, but I don't have enough time to explain everything. These are just a brief introduction about ICANN, but you might have many more information in our website, icann.org. There is a newcomers page. Just go and check there, and please let us know if you have any questions. Now, I stop here, and then I would like to leave floor to my colleague, Paul Muchene. Paul, over to you.
Oh, thank you, Seher, and very good afternoon to everybody. I would like to actually state that today we'll have a very exciting presentation on basically how to secure your DNS infrastructure. And to make things a bit easier, I'm going to break down a few of the things that Seher has mentioned, including who we are really, what the DNS really looks like. We've actually discussed about the security aspects of the DNS and also the vulnerabilities that the DNS actually is prone to. So let's go to the next slide. We'll start off with a very simple poll question. So what is the DNS? This one should be pretty straightforward, and I think we should have nearly 100%, let's just call it getting it correctly. So click or go to SLI.io and enter the number there. And Seher will share the results on the screen. Okay, so 2 responses, 4. Anybody else? Let's have at least half the number or more actually responding. Okay. 7, 8. Slide. Any more responses? Anyone interested? Okay, 10. We are now at 10. Let's try and get to 13, at least half the number. Okay, so let's go back a bit. Okay, so 12. We just need maybe 2 more, 1 more.
You may even type in the chat, but don't bother to go to the Slido if you feel hard.
If you're having a problem, yes, going to Slido, just type in the chat. And let's go to, okay, so the answer is basically A, the domain name system. And yes, I think everybody got it correctly. And let me explain a little bit what the DNS is to break things a bit, to make things a bit easier to understand. So, so you and I, we're engineers. I did computer science. And basically, the way the DNS can be viewed as is, you can say a tree, a graph. And a tree is basically a graph which doesn't have cycles. And a tree basically contains what you call the root. And beneath that, you have nodes and edges. So the DNS is actually designed to actually in a tree-like structure. And this tree-like structure, which contains the entirety of the DNS database, is known as the namespace. That's what we call it. So the entire DNS, a global DNS, can actually be viewed as a tree, and it contains one single namespace. And how this tree is structured is quite interesting. So you have basically the topmost node, which is known as a root node. So the root node is basically where we as ICANN come in. So this is the organization both Seher and I represent. We manage basically the coordination of all the domains from the very, very top of the tree hierarchy. And these domains are quite in a number. So if you look at the very topmost level from the root, you'll have domains such as .uk, .com, .coffee, .tr. And beneath that, now you have second level domains like example.com, google.com. Let's just call it abc.com. I'm just giving .com for example. And below that, you can even have other levels of that domain. So you can have like www.fyz.example.com and so on. So this is how the DNS is. It's actually a hierarchical structure. And we as ICANN manage the very, very topmost at the very root. And so I hope that clarifies basically how you can actually see the DNS in a very simple manner. Let's go to the next slide. So it's very interesting. The DNS actually didn't always exist. In the late 60s, when ARPANET, that's a precursor of the internet, that was the first packet switching network to operate, they never used actually the DNS. They used a very simple file. It is known as a hosts file, HOSTS, and it was a simple text file. And in this text file, you had basically the name of a machine. Let's say Seher, Ennis, and me, we are on ARPANET, and each of us has our own machines. So the host file will just maybe contain something like Seher's machine and the IP address of Seher's. It will contain my machine and the IP address. But this method couldn't scale because one is that in the ARPANET, the host file was changed periodically once a week, and not everybody got the same changes. At the same time, bandwidth in those days was very restricted, and therefore people downloading the host file itself could take considerable bandwidth. So around the early 80s, we're starting around 1981, two computer scientists, Paul MOKAPETRIS and Jonathan POSTEL, they actually conceived a way in distributing this, the host.txt file, and making it more decentralized. And in each case, they come up with the idea of actually the domain name system. So the DNS was born around this time, and the first, can I say, implementation of DNS took off in 1983. So between 1983 and today, we've actually been using a protocol that has actually significantly changed, but at the same time, the fundamentals have remained the same. And if you're very interested, I know many of you love the technical underpinnings, there's quite a lot of documentation, can I say, specifications on the DNS, and also additions to DNS. And I can share with you on the chart right now. You can actually look at what you know as the RFCs. This is a request for comments. These are technical documents on the DNS that have evolved starting from the early 80s up to recently. So you can actually have a look at that. So now that you understand the DNS from the point of view of as a tree, and also as its short history, let's go to the next slide. So I think, yeah, let's come a little bit closer to home. So we're going to start talking about how, for example, you yourself as an organization actually do rely on the DNS, but maybe in some way you may not know it because it is actually hidden in the background. So let's just say you run a company, and most likely you have various digital systems that you're running. And in these systems, you're storing internal data, such as your company's intellectual property, trademarks, copyrights, and also you're storing customer data, employee data, and so on. It doesn't matter whether you own the infrastructure, because today the cloud allows you to rent infrastructure. You could either rent it or you can actually own it yourself. But even if we look beneath that, what is actually this infrastructure? So this infrastructure that's used to process your company's data and digital assets consists of various systems. There could be various application-based systems. There could be various, operating systems that you operate that run different applications, and these systems are connected to each other through a network. And most likely they're using IP. Of course, they could also be using proprietary technologies to connect to each other. But if you look carefully at this ecosystem, we'll also see that basically the DNS actually features prominently here. Okay, go to the next slide. So when we actually look what is behind now, the infrastructure that you yourself are operating, you'll find that it is actually interconnected to various other, can I call it, nodes on the internet. And through what you know as can I say, it's interconnected through networks that are, okay, in the internet, what we call networks, they're known as autonomous systems. So let me break this down. So what happens is that every entity on the internet, and entities are basically ISPs, it could be governments, it could also be organizations like ours, ICANN, even academic institutions, those that actually volunteer, because the internet is voluntary, to connect to each other, they actually operate what you know as a network known as an autonomous system. So an autonomous system is an entity on the internet that operates and has its own network policies. And these policies are used for routing. So routing is basically transferring or taking traffic from one endpoint to another endpoint. And a good example is Turkcell. So Turkcell actually is an entity on the internet, and it has its own IP addresses, and it chooses how it wants to route whomever they want to. And they have an AS known as 16,135. Collectively today, as of 2021, there are over 100,000 autonomous systems. So there are over 100,000 entities that have their own IP addresses and choose to route. And some are very big, like Google or Facebook, and some are very tiny, that some are actually owned by even a single end user. But at the same time, besides now the autonomous systems that are responsible for routing, many of these systems actually use the DNS. The DNS has become such a fundamental protocol. It's 14 hours. Given how we actually have gone online through, maybe because of events like COVID. So the DNS has become more critical than ever. And what we're going to actually look at is why it is very important to secure the DNS. And also, because it is quite a critical system, we should actually ask the question, how do you go about protecting it? So let's go to the next slide. So one thing to note is that an organization can have various even domains. And if you look at a domain, think about it as also another digital asset. So if you're a bank and you're registered, you could have maybe be a bank.tr or bank.com. That could be a top level domain, but you could have several branches and locations, and each of them has a subdomain. So you could have location1.bank.com and so on and so forth. So it's still very important to understand that even with a single domain name, there's quite a wealth of information, and the such information can include the IP addresses of your locations. If you're operating a mail server, the mail server that's operated by the bank. If you're operating other resources like databases in remote and even near locations, all that is actually part and can be actually enumerated through the DNS. And so that's one thing you should also take note of, that even the domain itself is an asset, a digital asset. Okay, let's go to the next slide. And I'm just going to ask you a very simple polling question. So the DNS we've talked, we've stated it is actually, the namespace is a tree. And the nodes are actually domain names. So my question is, what are the components of the DNS? And the question is, what does it contain? Is it resolvers, authoritative name servers, client server, query? So just give it a shot. Let me know what you think. What makes up the nodes? Basically, the question is, what makes up the nodes and the edges in the DNS namespace? Okay, so one has given a query and response. Okay, majority. Okay, let's have at least a few more. Query response. $67. Okay, so okay, let's get to the halfway mark. Maybe one more response to make it 13. Okay, so okay.
Yeah, one adding point to option B, while Kabuk indicated his response in the chat bot.
All right, so the correct answer actually is the first one: resolvers, authoritative servers, and so on. Client and servers is still there, but generally a client and a server can be any, is too generic. So you could actually have, let's say, a web server and a web client. And although the web is actually uses a DNS, it's not really a component of the DNS. And basically, a query and response are just messages that you're sending between the various components within the DNS. So they're messages that are sent to a resolver. They're messages sent to an authoritative server. And I'll explain them in the next slide. So let's go to the next slide. So here are the fundamental components of the DNS. As I mentioned, those who got it, resolvers actually are very, form part of the components and are very, very important. So to give you a picture of what a resolver is, you actually get to use them quite a lot. So many of you have actually used Google's 8.8.8.8 or Cloudflare's 1.1.1.1. Whenever you are maybe checking your DNS settings, you're asked to enter an IP address. So the 8.8.8.8 is a resolver. In truth, that is what it is. And what these resolvers do is they receive your queries from your device. Your devices are known as stubs in DNS terminology. Your mobile phone, your computer that you use, they actually have a software known as a stub. So whenever you want to go to a site like ask.com, first of all, the request is sent to your stub, and the stub then sends now the request, now the query to now the resolver. The resolver then receives the query from your device. And then what it does, it actually does a very interesting thing. So your resolver sends a query now to another server known as an authoritative server. So an authoritative name server answers the queries. Its whole purpose is to answer the query. I'll actually illustrate this with a very practical example. So just bear with me. And in this case here, what it is that another thing is that it is very important that all this infrastructure, resolvers and servers, there are certain optimizations that are undertaken to improve on their performance. And other than that, another very important component is what you know as registries and registrars. So a registry is, for example, .tr. The Turkey country code top level domain is a registry. So a registry actually maintains a top level domain like .tr, and registrars are now ISPs, maybe a hosting providers, web designers who actually register a domain maybe under .tr. So for example, I'm just going to give an example. Let's call it sunlight.tr. I'm just giving an example, is now and is actually registered maybe through a registrar. And so that is basically the idea of the components of DNS. So let's look at a very practical example on how these components work together. So let's go to the next slide. Okay, so here's a very interesting example. Okay, I have WhatsApp on my phone. So I want to actually pull the messages that I've received from maybe my friends, my clients, and so on and so forth. So what happens is this. On my phone, I'm going to actually send a request to a recursive resolver. Why is this? Because as Seher mentioned, machines on the internet do not understand domain names. A domain name has to be translated to an IP address. And so WhatsApp.com has to eventually be translated to an IP address in order for your device to actually access the service on WhatsApp. If you're unable to do so, then basically you may not be able to actually get the messages you want from the WhatsApp servers. So how it works, now we'll take you step by step, is, first of all, I open my WhatsApp application. The WhatsApp application is actually interfaces with a very small piece of software on my device, on my phone, known as a stub resolver. So it checks the stub resolver if there's a corresponding IP address that matches to whatsapp.com. And if that entry is not in the stub resolver, the next thing is I'll contact my recursive name server. So this could be the Google 8.8.8.8. It could be maybe, let's call it the Vodafone or the Turkcell ISP resolver. It doesn't matter. So the recursive resolver actually receives the query. And the query that it receives is, I want to know from the stub resolver is, what is the IP address of whatsapp.com? Okay, so the recursive resolver, after receiving the query, it does a few things. First, it checks its cache. Cache, it's a temporary storage. It checks if it has the IP address in the cache. If it doesn't have the IP address in the cache, then the next thing it does, it sends a query to the root servers. The root servers actually provision the root zone. And I mentioned that we as ICANN, we maintain the root zone where on the root. So in this case, it sends a query to the root servers, and the root servers, it asks a question: what is the IP address of whatsapp.com? Now, it's very interesting. The root server will respond and tell the recursive resolver that basically, I do not know the IP address of whatsapp.com but I do have the IP addresses of the .com zone. Remember the tree, we are starting from the very top, the root, now we're going to the top level, which is the .com. So when it goes to .com, it sends the same query. It gets and it asks the .com servers, do you have the IP address of whatsapp.com? And the .com tells it, yes, I do, because the .com is authoritative for anything beneath that. And it gives a referral to the recursive resolver that the whatsapp.com zone, here's the authoritative name server IP address. And then once the recursive resolver receives the authoritative answer from the .com, what it does, it stores it in the cache. And then it sends now the query to the IP address of .com. That is now step 4. So in step 4, then it asks the WhatsApp.com authoritative server, what is the IP address of WhatsApp.com? Then after that, the authoritative server responds, and it gives now the recursive name server 2 IP addresses. It could be IPv4 and IPv6, or both of them. And it stores this answer in its cache, and then the recursive resolver sends the answer now to the stub on the device. And then from there on, the device is able to connect to WhatsApp.com and pull the messages and do whatever the user wants it to do. So that's how basically these components actually work together. Let's go to the next slide. But before I proceed, are there any questions, any clarifications, anything anybody wants to ask about the DNS, the components, their interactions? Please, you can go to the mic, or you can actually type on the chat. I'll be very happy to answer your question. Anybody, any question?
Yeah, I am checking the chat bot, but I do not see any questions so far. Paul.
Okay, so let's go on to this section of the presentation. So the DNS actually is pretty much, you can say, it is a core and a fundamental protocol which we all depend on for translation of domains to IP addresses. However, unfortunately, it is also prone to various kinds of attacks. And this is a very interesting part of the presentation. So what kind of attacks are there? And why is it prone? Why is it DNS? Why is it a target? These are the questions I'd like to answer. So first of all, I would like to bring into your awareness that before an attack is conducted, there has to be a planning phase. So in this case, an attacker basically needs to perform what you know as reconnaissance. Reconnaissance is basically determining the infrastructure, determining the kind of vulnerabilities, determining what kind of techniques they can actually use to penetrate a system and acquire maybe login credentials and other sensitive information that will allow them to actually take control of a system. And the DNS is actually, can I say, is no exception to this. Attackers regularly perform reconnaissance attacks on core DNS infrastructure. And this is because in the DNS, there's traffic that is actually sent to the resolvers and also to name servers. And if an attacker can actually be able to redirect DNS traffic and capture to perhaps, can I say, a machine under their control, then they can be able to capture a lot of critical information, such as login credentials. So you'll actually note that the DNS is a very valuable point of attack, allowing bad actors entry into your system. Let's go to the next slide. So why is the DNS a target? I'd like to start by saying that the DNS, first of all, has a lot of information, and you'll be amazed. And even and part of this is because it's a distributed database. And if you wanted to look up maybe certain information about a domain name, who the administrative contact is, where they reside, when it was registered, when is it expiring, there's actually a database known as the WHOIS. And the WHOIS has so much information about a domain. In fact, at ICANN, we are trying to actually phase out WHOIS. We want to go to a new protocol known as Registration Data Access Protocol, known as RDAP. This is because one of the reasons is regulatory changes. So the European Union passed the GDPR, that is the General Data Protection Regulation, in 2018. And it actually changed the, it actually changed the landscape in terms of privacy. So ICANN actually, the community has worked on a WHOIS replacement ever since then. And RDAP was basically the product of all the discussions. And this is in order to protect privacy. But another problem with also the DNS is that from the 80s up to until recently, the DNS actually has been fundamentally insecure. You should understand this. This is because during the 80s and the early days of the internet, there used to be, can I say, a community of trusted users. So basically, you found that Jonathan Postel trusted Paul MOKAPETRIS, and who trusted Vinton Cerf. And so they used to actually trust one another. And in that case, there was not so much thought given into security, adding security into the DNS. But as the internet became a very, very large, can I say, and successful project and network, then trust issues started to come, a compromise started to be there. So basically what you'll say is that there've been security extensions added to the DNS in order to make it more secure. So that's also another reason why it's a target for attack, because of also its insecure nature from previous times. And another thing is that you can also see that besides it being critical, you find it's also a target for attack because there are various ways of exploiting, such as maliciously registering a domain, hijacking even the name resolution. And it's also not too difficult to corrupt DNS data and also to poison the cache of a resolver. So all this points you should take note is to why the DNS is actually a vulnerable target for attackers. Let's go to the next slide. And if you see back to our components, and over here we have the stub, the recursive resolvers, the authoritative servers, the registry, and the registrants. There are various potential targets that the DNS can be compromised. So between your device and the recursive resolver, a man in the middle there can be a man in the middle attack and data exfiltration. Between other recursive resolvers and maybe the root server or the authoritative name servers, an attacker can introduce cache poisoning or data modification. And if you're a DNS operator and you're operating name servers, and usually most operate more than one, they have what you call a primary and a secondary, you can actually spoof the data between the primary and the secondary. That's a potential target of attack. Now, when you register a domain, so when you register a domain, the registry, the interface between the registry and the name servers, you can actually introduce data corruption if you're a skilled attacker. And even today, there are tools that even allow you to do that, even for those who are not so skilled. There are tools, open source as tools and exploits that can be used to do that. Then you have, between the registrar and the registry, you have a protocol that allows you to transfer domains. It's known as the Extensible Provisioning Protocol, EPP. If you can actually hijack the process of transferring the domain by getting access to the EPP keys, then you've actually been able to compromise even the DNS. And then finally, between you, the end user, who is known as a registrant, and maybe the hosting provider or where you register your domain, you can introduce various forms of man-in-the-middle attack. So you can see that these are the potential targets of attacking the DNS ecosystem. Next slide. And of course, it doesn't end there. What about the core infrastructure which the DNS depends on? Routers, switches, firewalls, and middle boxes. Those two are also prone to also being attacked. And even also how a network is also architected. If, for example, there are no DDoS protective measures, you may actually find that your network will just be flooded with actually, can I call it frivolous requests, and that is going to exhaust the resources. And so DDoS is also, some networks are also prone to DDoS. So let's go on to the next slide. And then another thing is, besides the infrastructure, what about the software? So if, for example, the DNS is actually bundled with different types of software in different operating systems. So you have software such as Bind, you have software such as NSD, you have DNS software such as Unbound. So the problem is this: if you're not patching your software, and for example, and research has found that maybe a given version of that software is actually vulnerable to exploits. So you actually are susceptible to actually an attacker using that knowledge of exploits to penetrate your system. So even you have to think about the software. And finally, also another problem is, besides the fact that DNS initially didn't have security in mind, wasn't designed security in mind, it has also evolved to become a very complex protocol. So I've shared within that document, it's the 277 specifications, which are over 3,000 pages, that have added more and more complexity to the DNS over time. And also when something is also a bit more complex, then it's also prone to actually breaking, or even prone to actually having bugs and other vulnerabilities being discovered. Okay, so let's go to the next slide. Okay, so before I go to the point of securing the DNS infrastructure, are there any questions on attacking the DNS, the kind of attacks, and if any questions? Feel free, don't be shy, just type, or you can raise the mic, or you can open the mic and ask the question.
I think you're super clear about the content pool.
Okay, so let us.
I see one comment in the chat.
We all do operations in domain. We are all, okay, maybe I'm trying to understand the question. We are all do operations in domain. Is the question is if the operations that we do on the domain itself, does it affect also the subdomains? Is that the question? Subdomain, is there much difference to our domain? Maybe Matt, you could maybe speak on the mic. I think trying to explain, because I'm still not getting the question. Please ask on the mic. You can talk on the mic.
Matt, maybe, yeah, I can. Okay, maybe you can just send additional clarification to your question, and then Paul can address it.
Okay, so maybe I'll just talk about a slight, so maybe I'll try and maybe answer this the best way I can. So let's just say a domain name is something like, okay, I'll just give an example, abc.com. So abc.com is what maybe you register. And then a subdomain is, let's say, mail.abc.com, right? So the thing is, the operations that affect a domain. So for example, let's just say abc.com is compromised. Maybe an attacker takes takes over the machine that hosts abc.com. So with the control of the machine of abc.com by an attacker, the attacker can decide to change the IP addresses of the subdomains. So if, for example, maybe your IP address for mail.abc.com used to be 1.2.3.4, an attacker can basically change that to maybe 3.4.5.6, which is basically under their control. So basically what actually happens is, if you actually perform certain operations on the domain and you're the domain owner of, let's say, abc.com, you can affect anything below the tree. So you can affect anything on mail.abc.com, ns1.abc.com, and so on. So in a way, there is, yes, there is a difference between the subdomain and the domain, because the domain, and at the same time, anything that you do on the domain, including making changes to it, can affect what can happen in the subdomain. I hope that tries to answer your question. Okay, but type in the chat if you need more clarification. I'll be happy to give you. Let me talk about some of the practices that are recommended, and I'll talk about them. I think a good number of you have come across this. So one of the things is that ICANN strongly recommends a set of cybersecurity measures to harden your local DNS infrastructure against attacks. So some of this are actually more in line with best cybersecurity and operational security practices, such as authorization, authentication, use of encryption, software patching, and also email security. I'll talk about each briefly. So let's go to the next slide. And also, okay, so I will start with zone integrity. So this is for those who are operating maybe a domain. Let's just say, for example, you are operating even the infrastructure of the domain. I'm not just talking merely of registering a domain. So you could register abc.com and maybe to a cloud service provider. I'm talking now the cloud service provider on that sense, who actually is managing abc.com. So in this case here, we recommend that basically periodic audits are done on the name servers themselves. So we also recommend that you check the source database that actually is within your infrastructure, and the actual zone file, which actually contains all the details of abc.com, including its subdomains. And we check that those haven't been compromised at all, that an attacker has not gained access to it, or perhaps some records have not been altered either accidentally or deliberately. So in this case here, because as I mentioned in the example I gave, that if the domain itself is compromised, any other record, including subdomains and everything, is also possible to compromise them. And so that is one of the things that within the zone itself, there are audits that are done. Another thing is also to review and validate the entries and the log files that are within that zone. So let's just say an attacker was able to get inside, and you may have to look at the log files of the host of that zone, the domain, and at the same time also check that the entries within the zone have not actually been tampered with. So that is zone integrity. But there's also another technology, and I'm going to talk about it, known as DNSSEC. I'll talk about it later, that actually helps in combating some of the issues that relate to the spoofing and also modification of DNS data. I'll talk about DNSSEC towards the end of this section of the presentation. So let's go to the next slide. Okay, so authorization basically asks the question, who has access to this system? Who can actually use this system in a legal manner? Who has legal access to this system? So when it comes to authorization, you have to think about conducting a thorough review of who has access, especially the root access to the DNS infrastructure. And at the same time, you also have to make some audit controls that basically root access is only granted to those who are trusted. So, and at the same time, also we recommend that the logs are actually reviewed to ensure that there's no unauthorized access to systems. So that's about authorization. Let's go to authentication, which is in the next slide. So authentication is this. Ask the question, you have already been authorized. Now we like you to verify that you're the person who has been authorized. So how do you verify that? So there are many various ways of actually performing authentication, and the most common one is passwords. So you're the root, okay. So you claim to be the root, so can you give us a password? Can you give us extra security, can I call it credentials, that show that you're basically, that verify that you are authorized to access the system? So that's basically what authentication is. So in this case here, if you're having passwords, you have to actually ensure that there's a sufficient degree of complexity in the password. You have to make policies out of their duration, how long the passwords are valid, that they are not transmitted in clear text. Another thing is also you'll have to put also other layers of security besides just only password protection, including multi-factor authentication. And also other than that, there could also be some other various forms of levels of authentication that you can use, like an authentication system, like Active Directory. You need to actually maybe authenticate using an authentication agent. So there are pretty other steps that you can also put here to ensure that authentication is being conducted well. Next slide. So patching is basically, software itself is actually, can I say, is prone to bugs. And this is also the fact that software has to always be identified. Bugs have to be identified constantly because bugs can be exploited. And once a bug is exploited, it can give a leeway for an attacker to actually compromise the system. So ensuring regular patching of software, adding security patches is also highly recommended. Next slide. Now, if you're operating a mail server, and some of you actually maybe hosting your own mail server independent of some cloud provider, there are other things that you can ensure that basically your email is actually delivered securely, and that that email that is received is, you can actually identify that it is not being spoofed or being modified. Some of the techniques that you can do is to add, you can actually use the DNS for this. So in the DNS, you can add 3 types of records in the DNS. One is known as a sender policy framework. The other one is domain keys identified mail. And the other one is domain-based message authentication reporting conformance. So I'll not go into the technical details of this, but I'll just mention that how they operate is like this. So if you're sending a mail, let's say to a recipient, and you've maybe put maybe one of the records like a DKIM, domain key identified mail, what happens is that every email that is sent from you as a user to the recipient has a corresponding digital signature. DKIM actually adds a digital signature to your email. This signature actually is not transparent. It's very hidden from the end user. So the system on the other side, it's actually a machine-to-machine system. So the system on the other side, the receiving system, will now look at that digital signature, will try and fetch the public key from the DNS. Then after that, it uses our public key to verify that the signatures are authentic. So these methods are actually used to prevent modification and spoofing of data by adding digital signatures mainly, to ensure that basically the recipient is the person that the sender is the person who claims to be, and it's not somebody fraudulent. And finally, let's go to a very interesting question. And this is for the poll. So one thing I've not mentioned is what is DNSSEC? So the question that is in the poll is, what is DNSSEC? So Seher is going to share the poll, and I wait to actually see your answers. So one person has responded. Let's see, 2. And in the meantime, let me try and address the question I got from Matt. Okay, so Matt, okay, thank you for clarifying your question. So you do have a domain name and you have taken measures to secure it. Now the question is this: the subdomains. The question is, if you have, let's say, a zone file, because domains are in a zone, perhaps maybe within the zone file, perhaps if you've already secured on the domain name, let's just call it that, I think it also makes I think it is also important to secure also the subdomain. So when I take security measures for myself, does it impact the security measures subdomain? So not necessarily, it really depends. So if, for example, I have the domain, I have a domain, what you call as a zone file. So a zone file now has the list of my domains and subdomains. Let's just say all of them are mapped to maybe or less the same, or are mapped to maybe various IP addresses. So I may have actually secured maybe the domain, the top domain, let's say abc.com. I'm just giving an example. But if I have, let's say I've delegated it. So delegation means I am now giving authority to perhaps another machine with a separate zone file to administer another subdomain mail.abc.com. So I still have to also take measures, added security measures to secure mail.abc.com, even if I have secured abc.com. So it is quite imperative that you also take security measures to secure your subdomains as well. I hope that addresses it. Okay. All right.
We have 10 responses so far, and the majority picked the first one. I don't know whether it is correct or not, Paul.
All right, so let's look at the answers. And so security extensions to protect data, DNS data, to protect the internet, to encrypt DNS data. Okay, so the answer is actually the first one. Let me explain why it cannot be to protect the internet. The internet is composed of various protocols besides DNS, and so there are various security extensions for various protocols. Like web is a very different system from DNS. Then it can't. Okay, so DNSSEC actually does have encryption, but then the encryption is not used to mask the data, that is to hide the data, that is that. It is actually used for integrity and authentication, not necessarily to encrypt the DNS data. So you'll still send DNS queries, even with DNSSEC, or that clear text, not encrypted. And the DNSSEC is supposed to check that the data that it is receiving from name servers and so on is actually authentic. So it is not necessary to encrypt DNS data, but encryption is still used. Let's talk about a little bit about it. Just a moment, please. Yeah, so basically the DNSSEC stands for Domain Name System Security Extensions. And it has actually been a standard that has taken considerable time to build. Work started on DNSSEC around 1998, and it was formalized in 3 documents, RFC 4033 to 4035. You can actually check the link I sent you earlier on. It should include documents on RFC. So I'll just type for all of you to actually check it out. So check RFCs 4033 to 4035. So DNSSEC is specified under those documents. And basically what it does, it actually introduces public key encryption or cryptography to provide assurances that the data that is received, that DNS data is actually valid and true, and there's integrity that's put to it. But DNSSEC is not as easy to implement, especially on the signing part. And so basically, it involves quite a lot of work for some. First of all, it is to sign the DNS data, and the second part is validation. So I will just mention, I think you can go to the next slide, Seher. So signing is like this. Okay, so let's just say I have a domain called example.com. So how DNSSEC works is as follows. First and foremost, you actually generate two pairs of keys. One key is known as a key signing key. I know this could be, just follow with me. I'll explain what these are. And the other one is known as a KSK. The other one is the zone signing key, or ZSK. Once you've generated this, you now actually apply the KSK and ZSK to your domain name, so example.com. And when you apply now both the ZSK and KSK to the domain name, that is what is known as signing. So your domain name now will actually have cryptographic signatures besides the usual records. So example.com will have an IP address, 192 whatever. It'll have maybe a name server record, ns1.example.com, whatever. And then on top of that, it'll have digital signatures. So once those signatures are in the domain name, then we say that the domain name is signed. But then why it is also a bit interesting how it works is that you need to establish what you can call a trust chain. And a trust chain is basically a hierarchy of signatures, you could say that, starting from the very top, which is the root, down all the way to example.com. So you have to create a trust at the root, then you have to create a trust at .com, and you have to create a trust now at example.com. So in other words, basically what it means is that for each of those layers of the hierarchy, each of those has to be signed. Example.com has to be signed, .com has to be signed, and the root also has to be signed, such that you can create a trust chain from the very top and to the very bottom. And another thing also, and this is why signing sometimes is sometimes a bit interesting and very, it's a bit nuanced, is you need to, the root needs to know that .com is signed, and .com needs to know that even example.com is signed. How is that known? How does the root know that .com is signed? How does .com know that the third level domain example.com is signed? So in DNSSEC, there's a concept known as there's another signature that you have to also generate besides the KSK and ZSK. It's known as DS. It's known as delegation signer. Delegation signer is just can I say a signature of one of the keys, the KSK, and for each of this, you have to submit the KSK to now the topmost zone. So if you're example.com, you submit the DS to .com, and if you're .com, you submit to the root. This is why DNSSEC is sometimes a bit, you can get lost, but from what I just want you to know is you need to create a trust chain, generate signatures for each of from the very top, the root down to below. And then after that, let now the parent zone know that you already have signed. And that's how you create the trust chain. Next slide, Seher. But there's also another part. So signing is one part and validation is the second part. So what is validation? Now, validation is far much easier than signing. And validation is not done by the zone administrator or the CCTLD operator or the registry. No, it is done by the network operator. It is done by the ISPs. So what DNSSEC validation does is basically it allows your resolver. Remember the resolver in the diagram, the 8.8.8 and so on. So the resolver now plays a very vital role. It starts checking, it starts doing, can I say, audits that the information it receives from the name servers, from the root, for example, from .com is actually authentic. It has not been tampered with by an attacker. So validation basically is checking the signature. So you signed the root, you signed .com, you signed example.com. Are these signatures valid? So DNSSEC validation is supposed to perform that part, and it's done by the resolvers to check that basically the signatures from the various components, the name servers, and such as a root, example.com and so on are actually valid signatures and have not been tampered. In this way, you're able to prevent, let's say, an attacker from spoofing DNS queries. Because if an attacker decides, okay, they're going to take over example.com, and example.com has been signed, and they change the IP address or something, a resolver that's doing validating is able to detect that there's something that has been changed, and therefore it can refuse actually to answer queries from example.com. So that is what validation does. A very important thing to note, and this is something also we do at ICANN, and it's what is known as a trust anchor. So basically at ICANN, because we manage the topmost level domain, the root zone, we need the internet community and all users to trust it. We want you to trust the root zone. And how do we create this trust? How do we actually ensure that what we are serving you is genuine, it's not spoofed, or the signatures have not been tampered with? We have what you know as a key signing ceremony, or KSK, in which case when we generate the key signing key for the root zone, we ensure that the entire process is viewable over YouTube, over various channels, such that you can audit it, even you as an independent user, to ensure that all the processes that we're conducting is transparent. And once the root zone is signed, we share now the signatures of the KSK with all the resolvers across the world. And that now forms what is known as a trust anchor. So we actually have our own process to ensure that the integrity of the root zone is maintained. And I think now we can go to the next slide, which is we can go to the next slide. Are there any questions on the measures, especially DNSSEC? Are there any questions? I know DNSSEC can be a bit complex, and we usually have a separate webinar on DNSSEC, which is slightly more longer, where we go into the details. But are there anybody who needs clarifications? Any questions? Okay, so I'm going to actually go through the evolution of the DNS. So as I mentioned, the DNS is always evolving, and there are new additions to the DNS. I will speak about the most prominent ones because they affect they've actually affected the ecosystem in a big way. And some of them have added even complexity. I'll talk about IDNs. So let's go to IDNs and the next slide. So the internet has grown from basically a few researchers who predominantly were in the United States and some in Europe, to now a global network that encompasses all the continents and every country in the world, and over 4.7 billion users. And you see, since people speak in various languages, it is very important that there's representation of those languages on the internet, and especially in the domain name. One of which is, and this is where IDNs come in. So internationalized domain names basically allows now end users to actually register domains in their own script. So traditionally, domain names have been in the Latin A to Z script, like .org, .com, .uk. But IDNs allow now those domain names to actually be in the local languages, like you have seen in this one, .arab in now the Arabic script, .china now in the Mandarin script, and .rf now in the Russian or Cyrillic script. And so IDNs have actually being implemented, and various CCTLDs are doing this, including Turkey. Also implementing this. The problem is that not many, and this is the biggest problem, as much as the support for IDNs on the top level domains, and even country code top level domains particularly, most of the software, such as email software, such as even databases and all, not all of them understand these scripts. Not all of them can translate these scripts into and resolve them into IP addresses. This is why ICANN is working on a very big project known as universal acceptance, which actually where we actually work, we sensitize and work even with software vendors to ensure that they can actually support these various scripts and translate these various scripts into code that can translate them into IP addresses. and or can say it's compatible with the current with the current software. So let's go to the next one. Another also addition that has come to the DNS is emojis. Now, I know all of you use emojis in one way or another, but as much as they're fun, yes, well, who then want to have a smiley .example.com or .tr? That's all fine. The problem with emojis is that they can be too visually similar and it's very hard to distinguish. So a good example is you can confuse this grinning face, you can see on your left-hand side, with a grinning face with smiling eyes on the right-hand side. And this can actually, just go to the next slide. Let's go to the next slide. So because they're visually dangerous, just think about this. Just take a practical example. So basically, maybe you register an emoji domain and it is maybe that's grinning face. Then an attacker, and it's maybe grinning face.example. And then an attacker decides to also register a similar looking emoji domain.example. And then think about the implications of this. Supposing you run a critical service on your emoji domain. So if an attacker also registers that, they can actually spoof even your site and even get end users to actually come to the wrong site. So the problem in emojis is because they're visually similar and it's very hard for end users to detect them. And they're also rendered very differently on different devices. It can actually be used also as a vector for an attacker. So this is the biggest problem with emojis. And you can also see this. And another thing is also emojis keep changing. So you can also, on the right-hand side, you can see the detective from yellow and different shades of colors. So that also can also be quite confusing to end user. And let's go to the next slide. So it's quite interesting that at ICANN, we've actually, the community known as the Security Stability and Advisory Committee has actually tackled this issue of emojis in the domain name system. They have actually crafted a document. I'll share with you the link to this document once I'm done, known as SAC 095, which is an advisory on use of emojis in the domain name system. What the document states is they actively discourage users and even domain name registries from actually, can I say, applying emoji domain name systems because of the various security risks that can be associated with this. However, as I said, in ICANN, since the policies are created and accepted voluntarily, not all, can I say, registries adhere to this. So you do have certain registries, and I think you do have certain registries. A good example is Kazakhstan. Actually, if you register, Kazakhstan.kz allows you to actually register emoji domains. So registries, because CCTLD registries, since they're independent, they're autonomous, they are not bound by ICANN rules, or even they can choose to even ignore them because they're autonomous. Some of them offer actually emoji domain name registrations. It's just only to let you know that even though there are advisories against using them, other parties do allow still for registries for emojis to be actually registered. Next slide. So thank you.
Paul, there is one question in the chat but about the decentralized DNS, but would you like to address this now or at the end of the slide?
Decentralized DNS and the decentralization evolution DNS. Oh, this is a loaded question, Ennis. So let's just say this. Okay, so DNS is decentralized as far as you can say the database is decentralized. It's under various parties. What is actually centrally managed is actually the coordination from the root down to the various second and third level domains. So because it's a hierarchy, and this has been, because it's been a historical, I'll say it is actually been through historical reasons that initially the DNS, even starting from the host.txt file, was centrally managed. However, if you're talking about blockchain, okay, so I know where you're coming from. So blockchain, it does allow you to actually decentralize, of course, because you're actually adding, let's just call it, you're adding maybe transactions to the block itself, so from a chain, and that is highly decentralized. The problem is adopting it. So here's the thing. If let's say somebody says, okay, we are going to actually offer a blockchain service where we're going to actually register domains. I'm just giving an example. So you're going to be registering domains from the blockchain. The idea of adopting it is a very wide scale, and we're talking of in the millions of users and so on. That is where things actually become interesting, because as much as somebody may scream that, yes, the internet has become too centralized, we need to decentralize, and blockchain is a solution, adopting maybe blockchain, not just for Bitcoin. I know Bitcoin is, and also other coins is a different story. There's wide adoption on that. But of maybe registering domains, for example, through the blockchain, that is another problem. So adoption of protocols is a big undertaking. A good example is IPv6. Just tell me, it's nearly taken more than 15 years for IPv6 to be adopted. So adopting new protocols to do as replacements for maybe certain tasks or certain protocols isn't a very easy process. So that's all I can say about it. Oh, okay. Ennis, where is it? Ennis, I think this is, I may not be competent to talk about decentralized identity at this point. I think this is beyond me. I wish maybe if we had maybe a member of our policy team, because they actually talk about this quite a lot, they would be able to give you a more definitive answer. And I'm sorry, I'm not in a position to do that. So I will just talk about DNS over HTTPS. Just basically, this is another addition to the DNS. So this is a very interesting protocol, and it has actually caused waves across the world, especially some legislatures have even commented about this. So DOH actually allows you to send encrypted. Now, this is where we're talking about encryption. We're not talking of DNSSEC here. We're talking of encrypting the queries themselves so that the queries are masked. They cannot be seen by an eavesdropper or even by the ISP or even the government or so on and so forth. So how this is done is basically whenever you go to a website, you actually have this lock you see on your browser. And that lock tells you that this website is actually HTTPS. So DNS over HTTPS allows you to send DNS queries to now the resolver between your end user device and the resolver through the encrypted web. So you're sending both web traffic and DNS traffic over an encrypted channel. One of the things is that it actually bypasses now maybe certain network policies set by ISPs. And as much as this is good for the end user because it gives privacy, the problem is that it may be bad for network administrators and ISPs. And other thing is also it may go against even national legislation and also local policy. At ICANN, we have the department I work with, Octo. We've actually published a paper called Octo 003. Sarah will share with you this, where we actually give our policy position as ICANN on the use of DNS or HTTPS. It's we can share with you. It's a very interesting read. Octo 003. Sarah will share with you the link. And so let's also talk about the next one, which is
yes, I will share the link in the chat, but no worry. So
you could take a look at Octo 003 on our position on DNS over HTTPS. DNS over TLS is a bit different. It's similar, but it works this way. So in DNS over HTTPS, you're sending together with web traffic. So you're sending over port 443. But with DNS over TLS, you are actually sending over a different port 953. So what happens is, it's similarly, you create between your device and the resolver an encrypted channel over port 953, and then you send DNS traffic. It's 15 hours. So that's DNS over TLS. So DNS over TLS is less controversial than DNS over HTTPS because it's easy to block port 953, and it's very hard to distinguish between encrypted web and also encrypted DNS if they're sharing the same port. So this is one thing that can also be used, and it's also another innovation that has also created waves in the DNS ecosystem. So next slide. Okay, so that brings me to now I only have, this is actually our one of the last topics, and this is on DNS abuse, as we saw it during COVID-19. Let me just mention this, and then we'll have a Q&A session at the end.
Yeah, so, Paul, may I interrupt you for a second? We are at the top of the hour. Maybe we can just wrap up the last slides within 10 minutes, and we can go back to the audience whether they have any questions. Would that work for you?
Sure, that would be quite okay. So during COVID-19, we actually were able to analyze some of the domains that actually we thought were susceptible to abuse or were actually being exploited for abuse purposes. And we actually categorized these domains in 5 major categories: whether they're phishing domains, whether they carry malware, whether they're part of a botnet, command and control. And for those of you who don't know botnet, so a botnet is basically a network of computers that have been infected. And those infected computers are sent instructions by what is known as a bot master to do nefarious things such as DDoS, infecting others, also spam. And then we also categorized abuses as spam, whether some of the domains are actually responsible for sending unsolicited messaging, and farming. So farming is a bit on the higher side, it's on the website. So this is whether some of them actually were redirecting or being redirected to fraudulent sites through DNS hijacking or poisoning. So let's go to the next slide, Seher. So basically, COVID-19, we saw anytime there are important events such as COVID-19 and working from home, especially, there are actually spikes on the network, and this is not unusual because anytime it's a very important event, there's always huge network spikes. So that is one of the things. So it is not really unusual to see such spikes. Next slide. However, how we actually categorize these domains is as follows. So first of all, we actually get a list of English-related terms, such as COVID, corona, pandemic, COVID-19, and so on. Then we actually boost now those terms by actually adding other parameters, such as that are related to COVID, such as lockdown, hydrochloroquine, SARS-CoV-19, and so on. Then we actually translate these terms into various languages. So we translate them into Turkish, German, and various languages. Then we also look for terms that were known as homoglyphs. So homoglyphs is, for example, instead of COVID, you replace maybe the O with a 0, or you replace the I with a 1. So those are just variations of maybe a given term. And then given that, now we actually look at terms that are benign. So benign, that is, they are not malicious. For example, coronation. Although coronation has corona in it, doesn't necessarily mean that it is bad. So you have coronation, and so we remove those terms from our list of terms. Then we translate some of those terms from now the non-Latin script into Punycode. And then once we have this, we have an entire list, a dictionary, you could say, of several COVID COVID-related terms. So how does this work? So what happens is between January and November 2020, out of 248,718 domains identified with those terms, we found that only that 9,000, let's just say that, and that is the blue line, that 9,194 have a degree of misuse. But with a high confidence, the rate is even less than 1%. It's 2,573, okay, close to 1%. So only 1% of those domains, actually, we could say, actually high confidence that they're actually being used for nefarious or malicious activity. So next slide. And we also did some analysis, and we found that of the terms that we got, from COVID, vaccine, mask, and all, 94% of those were in English. And then the other languages, the closest was German, which is 2%, and it goes down. And so that's to let you know that 60% of the domains used 4 related keywords. And of course, most of these are in English. They use the term COVID, mask, corona, and virus. Next slide. But what we do then, and how this happens is once we get all these terms, we now look at those domains and we compare them with reputation lists. And there are quite a number of reputation lists, such as VirusTotal, PhishTank, Google Safe Browsing, and we check those records to see the behavior of those domains. And then from there, we are able to generate reports, and we send them to now the registrars and registries that already have contractual obligations with ICANN. So that's how we've been able to analyze COVID-related domains and report them to the various parties to take action on them. So, and also to share with them and also for them to take action. So now this is the final word, and I think we are within our 10 minutes, I hope so. So we've talked so much about the DNS, about the various attacks, and how we can actually secure it. So there are various ways to secure the DNS, apart from DNSSEC, apart from all the authorizations, authentication, and security, operational security measures I put. You should also note that this is not complete. Another thing also that helps is also regulation, and also I'm not saying it in a bad way, but for example, also measures by also maybe individual parties and even governments to improve the cybersecurity posture can help actually add another layer of security to also your DNS infrastructure. And this is just only an example on how some of these technologies can be deployed on various levels of the DNS ecosystem. And let's go to now the very final slide. So in conclusion, I just want to say is that the DNS is no longer just a technical function, just purely run by network operators. It has become such a critical piece of infrastructure that we use in our everyday lives, from email to apps to social media. And also within internal systems in an organization, it is still critical. Therefore, it is also critical that not just only the technical community and also operators, network operators, it's also important that policymakers and decision makers pay attention to the DNS infrastructure, because if the DNS is compromised, then basically even your systems and your network are at a very serious risk. And that brings me to the very end of our presentation. And if you go to the last slide, you can reach us at icann.org and follow us on our various social media and all those feeds. So that is the end. And I think, a bit sorry if I have taken, I think I have 1 minute to spare.
You are perfect on timing. Thank you very much, Paul. And you covered everything, but I just want to reiterate that we will continue our efforts to improve capacity in Turkey with regards to DNS. And Paul is one of the main contributor and the leader of this capacity building webinars. So this is one of them. I hope everybody enjoyed it and would find it beneficial. And I would like to leave floor to Enis Karaaslan.
What can I say? Thank you for your efforts and thank you for your contribution. Here in our computer engineering department, we are trying to give on-field knowledge and up-to-date knowledge, and you are always more than welcome for other sessions as well. Not all, it shouldn't be always related with a lecture. We can do some online events and others. What Seher was also mentioning was there are also some opportunities, ICANN opportunities for students as well. Perhaps we can also talk about this.
Absolutely, I would like to do it. I just want to share my screen again. I know you got bored seeing my screen whole day, but as Enis Hoca mentioned, ICANN has some programs for youth and young professionals. One of them is fellowship program. This is for young professionals, but it doesn't matter you are a student or young professional. You just need to be interested in internet and DNS ecosystem. So that's why with this program, people can come and join us at ICANN meetings. ICANN meetings are held 3 times in a year, and they are being held in different parts of the world. But within the corona pandemic, of course, we moved into the virtual environment, but at some point we will go back to face-to-face meetings or at least hybrid meetings at some point. Apart from this, we do have some regional events as well. Please just follow us on social media. You can just follow us at ICANN. We do have social media handles on Twitter, LinkedIn, Facebook, and even Instagram. And I am also working as a regional specialist. You can reach me, you can reach out to me anytime if you need. So you can follow us on our regional events. You can join us. And we always welcome our Turkish stakeholders to join these activities. For example, Enis Hocam, if we would like to just create those activities together, we would be more than happy. That's all. And there is another program. It is called as a NextGen program. I shared all the links with Enis Hocam, so he can share with you. NextGen program is specifically targeted for students, university students. If you are a current student at this university, I mean, this would be a good opportunity for you to apply. Just to clarify, you can only apply ICANN meetings which is held in Asia Pacific region. For example, we will have a meeting in Cancun, Mexico, but since it is in Latin America region, Turkish applicants cannot apply to that region. You just need to follow the meetings happening on APAC region. APAC, I mean Asia Pacific region, and Turkey is part of Asia Pacific region in our mapping strategy. And that's all. There is a lot. There is a lot about ICANN. But this is just a introduction. You can always reach out to me. As I said, I will share my email address in the chat pod. And please keep an eye on these programs, fellowship and NextGen programs, because I believe that those are good opportunities to join ICANN community and to get specialized in DNS. For example, Paul is one of our fellow back in 2017. Paul, do you want to elaborate on this?
So the fellowship, you can actually apply more than once, at least 3 times. So I was a fellow in 2013, 2014, and 2016. Then I became a coach afterwards. So I have actually gone through the fellowship thrice before I became a staff member. So I'd really, really encourage you to join the fellowship. You'll meet not just, you meet various people from engineers to businessmen, to businesswomen as well, to even civil society. It's actually a very, very good program, and I highly encourage you to join it.
Yeah, now I'm showing it's the program webpage. I will also share the link on the chat pod. Yeah, that's all from our side. If you,
I would also,
please.
I would also recommend my students that there are also other organizations like RIPE and others, and they all have such opportunities, scholarships and other things as well. For example, for the field of internet governance, there are also some activities where you can understand how the internet is managed, and you can just, yeah, you know, there is the ISOC Turkey, which I am also a member, and these ISOC and others, just be a member of it. My students are just, we have this computer networks lesson, advanced computer networks and security, and other network-based lectures as well. So I would also recommend them to attend these international events. By these, we just met, right? So
Yeah,
we
that's
meet
right.
each other, and then we share knowledge, and it will go to, I hope, a brighter future, of course. So hope so. Peace.
Hope so, right.
Yeah, you know, when it comes to the decentralized DNS, I know it has a long way to go, but I am a bit more centralized, not centralized, but focused on decentralized identity. And what I think is we may have not a domain name service, but we may have like kararslan.io name, and we may just use different subdomains like our MSN address, our WhatsApp address, our currency wallets and other things, and we may control it ourselves. And I guess it's going to, it may go to such a direction.
I think we have a lot to talk about this, the blockchain.
Probably in another session. I would like to also invite your colleague as well to talk about.
Yeah, but our Office of Technology Officer, I would say they do have some publications on 5G and IoT. But you know, all these new technologies are not falling ICANN remits. We are just particularly focusing on DNS and unique identifier systems. But maybe in terms of 5G and IoT, they just have released some papers to show our approach on this. But I believe we are not in a position to talk about blockchain, right, Paul?
Okay, so basically how we do this is we look at a new technology and we research it and we see how it actually affects the DNS. And my colleagues at Octo have drafted papers on new IP or non-IP networks and how they actually tackle the DNS. If you look at the publications that Seher has actually shared with you, there are publications on these new technologies, evolving technologies, and the impact on the unique identifiers. So basically, if you like us to organize maybe a discussion, which will give from our own perspective of what we think of these technologies and how the impact they may have, let us also know.
Yeah, I would be more than happy. Yeah, why not?
Yeah, that would be great. And I also would like to thank you again, Enis Hocam, for just inviting us to this lecture, and also patience of our audience. Thank you for following us and bearing with us throughout this presentation.
Your time also. Thank you.
Okay.
So I'm just stopping the recording. Thank you for all for attending.